Assalamualaikum and hello everyone, especially for Dr. Gus. Today we will do our presentation on assemblage of USB fan assembly. Today we are at Manual Operation Learning Factory. Today we will walk you through our time study, workstation design, and process improvement of assembling 900 pieces USB fan per day. Hello, my name is Nurul Akashah binti Ismail, PD23008, and this is my group members.
Hi, my name is Filza Nazirah binti Yuhyi. My matric number is PD23043.
Hi, my name is Nurzakiah binti A Halim. My number matric is PD23013.
Hi, my name is Adibah Balqis binti Nizam, and my matric number is PD23002.
My name is Boon Hui. Matric number is PD23009.
The process begins by carefully inserting the motor into the housing to ensure proper alignment and stability. The motor is then secured using screws so that it is firmly fixed and ready for the next assembly stage. Next, the fan blade is attached carefully to make sure it is installed correctly and can rotate smoothly. After the blade is installed, the assembled fan is placed into a container. The container keeps all parts neatly organized and easily accessible, helping to improve workflow efficiency. Finally, the assembled unit is transferred to the next workstation for the following assembly and inspection processes.
Next, I will assemble the USB fan frame with the USB fan stand. First, I place the USB fan frame in the correct position and carefully align it with the USB fan stand. This assembly step applies the Bolqis principle, where the screw holes on the frame and the stand are designed to match only in the correct orientation. This helps prevent incorrect assembly and reduce human error. Once the alignment is correct, I insert the screws into the designated holes and use a screwdriver to tighten them gradually. I make sure each screw is tightened properly so that the frame is firmly secured to the stand. After all the screws are tightened, I perform a quick inspection by checking the stability of the frame and ensuring there is no looseness. This ensures the USB fan can stand properly and operate safely. After completing this assembly step, I pass the assembled USB fan frame and stand to the next section for the following stage of the assembly process.
Workstation, my role is to inspect the USB fan to ensure it meets quality standards before packaging. I start with a visual inspection to check for any defects such as scratches, cracks, or misaligned parts. Next, I make sure all screws are tightly secured and that all components are properly assembled. I also check the wiring to ensure there are no exposed wires, leakage, or defect that could affect safety or performance. After that, I test the fan by plugging it into USB power source to confirm it functioning properly. Once the product passes all inspection, it is approved and sent to the packaging process.
I am responsible for the packaging section. After the inspection process, I receive the USB fan along with the fastener in the packaging area. First, I make sure the charger is properly secured by tying it together with the cable using the fastener. Once it is secure, I pack the USB fan into the box and ensure that the manual book and all fan components are included. After that, I close and I seal the box to make it more secure. Finally, I place 6 boxes of USB fan into a larger box and transfer it into the loading section.
I am ensuring the seamless transportation of SMP USB fans from the end of the packaging line to their designated final storage location. After the final quality check and packaging, the fans are carefully arranged onto specified field trolley. We is storing a PC base of 20 units. I then initiate the first step of transport by moving the roller trolley onto the calculated convenience system. One of the roller states the trolley travel along a swift, optimized roster to the factory. Upon arrival at the warehouse sharing area, the process shifts to manual validation and organization. Following this, the fans are transferred from the trolley and stored on clearly labeled shelves organized sequentially by production date and model variant for perfect stability and free-for-short rotation. The entire chain line flows from the automated system of the calculator to the efficient of the roller straight is designed to support our daily production target of 900 units without delay or error. For calculation part, we analyze daily sizes for a USB fan production line, focusing on the key link metric. They tell us how to set up and balance the process. First, we start with demand. The daily capacity required is 900 units and we have 28,800 seconds of available time in as 8 hours per day. This let us calculate the task. We divided available time by demand is using 28,800 seconds divided by 900 units, giving us a task time is 32 seconds per unit. Still means we need to complete one fence every 32 seconds to meet the daily goal. Now the analysis shows a total cycle time. It is mean that the sum of all work elements for one unit is total 1,243 seconds. This is a significant amount of work content. To figure out the minimum theoretical for being on our line, we calculate the minimum number of rotation. This is done by dividing the total work by the task time is 1,243 seconds divided by 32 seconds per unit equal approximately 38.84. Since we cannot have a fraction or a rotation, we round up, indicating we need at least 39 rotation to theoretically handle the loads. Next, we look at SWIP equals standard work in process. This tells us how many units will be in the system and want to maintain for. The formula is the same, is the total cycle time divided by task time. Using the 1,243 seconds, we get a SWIP of about 38.84 units. We align with our rotation count, suggesting we all typically has about 39 units in various states of completion. Finally, we assess the line balance by calculating efficiency. The document shows a calculation using a total cycle time of 1,243 seconds and the 39 units from the minimum rotation calculation. The formulas is calculate efficiency is using the total cycle time divided by number of rotation multiplied by task time. All times is 100%. So we using 1,243 divided by 39 rotation and multiply 32 seconds times 100%. This result in an efficient or roughly 99.7%. It shows very high accident prevalence, likely refers to the work being well reputed but the number itself fed a potential capacity issue where demand might not be met without overtime or process improvement.
To conclude, this assignment helps us to understand how line balancing works in a real production process. Our team conducted a time study for the USB fan assembly, inspection, and also packaging. And we also calculate the time based on the target of producing 900 units per day. From this, we were able to decide the number of workstations that needed and arrange the tasks properly to make the production flow smoother. We also designed a production jig and applied poka yoke to reduce mistakes during the assembly process. Through this project, we learned how important efficiency, accuracy, and teamwork are in a manufacturing environment. Overall, this assignment gives us hands-on experience and help us to connect what we learn in class with real industrial practices.
Makes it harder to see underneath. Did we ever know? Did we ever know? Did we